Hello, good afternoon, everyone, dear authors and invited guests. Welcome to Technical Session 8C. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Search Foundation and GS Holistic LLP, it's my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19th to 21st of January 2026. I hope that you will enjoy this knowledgeable interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes to the presentation and 2 minutes for question answer. On 9 minutes, I will raise a gentle reminder, and it is requested to everyone kindly adhere to the time limits. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or remark, you can write it to me in the chat box. Before getting started with the session, I would like you to introduce with our today's session chair, Dr. Jaideep B. Patil. Dr. Jaideep B. Patil is a Dean School of Engineering and Technology, D.Y. Patil Agriculture and Technical University, Pune, India. With over 13 years of experience in academics and industry in the information technology domain, he has published 21 research papers, authored 2 books on Python, and hold 2 copyright. Actively engaged in teaching, research, and outreach, he conducts workshops on Android development, network security, mentors and mentor undergrad projects, etc. Now we will be moving towards our first presentation of the day. For the first presentation, I like to call Swatija for the paper title Agentic AI Job Consultant and Autonomous System for Personalized Job Search and Career Coaching. I request the presenter to kindly proceed with their presentation.
Good morning, sir.
Good morning, ma'am. Please proceed with your presentation.
Okay, sir. I'm T. Swatija. I'm going to present our paper titled Agentic AI Job Consultant and Autonomous System for Personalized Job Search and Career Coaching. This paper focuses on building agentic AI job consultant. It acts like a virtual career assistant that helps user to find a stable jobs, prepares their interviews, and send personalized job alerts automatically. Today, job markets and candidates spend a lot of time for job searching in multiple platforms. Most platforms are manual and do not provide accurate skill based matching. They also lack personalized guidance and interview preparation support. To solve this problem, we propose an agentic AI job consultant that uses AI, ChatGPT, and intelligently match the resume with jobs and assist candidates like a human recruiter. This problem statement is about the main problem is inefficiency in job searching. Traditional platform depends on manual browsing, which is time consuming. They fail to accurately understand the candidate's skill and job requirement. As a result, candidate miss a relevant and good opportunity, faces a frustration during a job search. Our objective is Our motivation comes from real challenges faced on job seekers. Manual search and poor job matching, lack of interview preparation, and delayed notification reduces successful changes. So there is a need for automated and intelligent job assistant. So we prepared this kind of project to automate a job discovery from trusted portals to accurate match resume with the job posting using similarity and to generate a short AI based job summaries to create mock interview questions using ChatGPT These are a process we used to create this project. The abstract is about, in summary, our system works as a virtual career job assistant to automate job discovery. It improves the resume to job matching and generate a job summaries for easy understanding. Using ChatGPT, it allow provide role specific mock interview questions and personalized alerts. Overall, it improves the efficiency, accuracy, and use experience in job searching. And it scraps information for 5 years and it sent to the user to inform about the job. The remaining part, my co-author Neela will explain. Sir.
So I will continue from here. I'm Nilaver Lovia, the co-author of this paper, and I will start by presenting the existing systems. So several studies have explored the AI-based job matching, but they primarily focused on retrieval and recommendations. For example, the paper titling Learning to Retrieve for a Job Matching Using Transformer Based Semantic Embeddings, it demonstrated in matching increasing the accuracy, but it does not address the downstream tasks such as the user guidance or the interview preparation. It does not address that. And another paper titled An Empirical Job Matching Model Aligned with Human Recruiter Judgments, it also helps in providing a good matching quality, but in nature, it does not provide any assistance, personal guidance to the systems. And then the project title named Computers in Human Behavior. From that, we learned to gather the usage of GPT-4 in finding how it is used in the assistance, and the proposed system and advantages. We proposed a system, and the title is Agentic AI Job Consultant, and it is designed to be fully autonomous with a constructed pipeline, and it is a standalone recommender. So it also the job listings are automatically collected from trusted portals like Intentshala or Naukri or the platforms, and then the resume to job matchings are performed by semantic embeddings, allowing the system to look in detail rather than the keywords, but match according to the meaning of the job that is searched for. And the GPT-4 is employed to generate concise job summaries, or whether what the job is provided for, like who it is intended to and what they do in the job, to give precise summaries. And personalized notifications are delivered to Telegram, WhatsApp, and email. And then mock interview preparations. It adheres to the user's capacity and their preferences. And similar questions and interview questions are tailored for each and every roles. And the architecture. I will now outline the system architecture. The workflow begins with the user uploading a resume in a PDF, document, or text format, and then the text is then processed through sentence transformers, which will produce the semantic embedding representing skills. They will identify the terms and they will search for the meanings through various online platforms and look for the in-depth in what the job or the keyword explains. And these embeddings are stored in FAISS, a high performance vector similarity search. And it works through nearest neighbor retrieval. Simultaneously, a job scraping model collects the descriptions and things from platforms like Intentshala, LinkedIn, and Naukri, and the both keywords from sentence transformer and the job scrapping are matched towards each other. And before matching, GPT-4 probing is applied, where it defines and contextualizes the jobs to enhance the alignment properly. And similarity computation identifies top 5 relevant jobs, and it will provide us. So finally, the results are delivered through Telegram, WhatsApp, and email notifications. This can be done for every 5 hours, which is the specialty of our paper. In conclusion, the agentic AI consultant demonstrates how the agentic AI systems extend beyond recommendation into nurturing and helping us through the career by guiding us. And by combining semantic embeddings and job discovery, generative summarization, and also interview preparation, the system enhances both matching quality as well as the readiness of the candidate to attend the job interviews. This work illustrates the practical potential of any AI agent in transforming the recruitment of the workflow. And for the future work, we have a plan to develop some interactive dashboard using React or Streamlit if this works successfully. And then integration with global platforms like partnering up with LinkedIn, Indeed, Glassdoor will also improve the job search relevance. And we also plan to introduce a feedback mechanism from which, by the feedback of the users, the system would train itself to give more positive reviews. Thank you for your attention. We welcome any questions or discussions. Thank you.
Thank you, Bam. I have just one question that you have mentioned that you will be using GPT-4. Okay. So GPT-4 have a problem of context window. It has a very short context window, and you say that you will be indexing them with resumes and job scrape data. So how will you handle the little context window that GPT have, or to prevent it from hallucinating or perform, like producing hallucinated results? Is that audible?
Yeah, yes, sir. Audible. So yes, you're absolutely right. It has limited context window. Our system does not rely on GPT-4 to handle large job data, right? Raw data. It will architecture around the context limitations. So it is not completely used for the job scraping. So it will only how to say it will handle the scraping module. The job scraping will handle the module. The GPT-4 it is never exposed to the raw HTML or bulk job listings. So and also once jobs are scraped, each job description is cleaned, structured, so that they are token safe. They are made token safe segments. So only compressed and only shortened content will be passed further. This will minimize any other confusions from happening.
Perfect. I have one more question that you have said that you have a skill matching technique, a semantic search, no, on that. So what technique are you actually using over here? Are you using the simple Euclidean phase technique that ATS use, or any other technique that you have brought from your side?
So the system actually uses the transformer-based sentence embedding model. Specifically, it is called the sentence transformer, and it will convert the resume data and the job description data into semantic vectors, so that, for example, statistical modeling and data analysis. These are the two keywords that are got from there, and it will convert it into vectors to identify and match rather than extracting complete passages. We use that, and also we also use FAISs and vector similarity matching, so that it gives more accuracy.
Perfect. Now let's move to the next presentation. For the next presentation, I like to call presenter Srinivasulu A for the paper title Android Malware Detection Using Machine Learning Techniques. I request the presenter to kindly proceed with their presentation. So now you can share your screen.
Good morning, one and all who are present here. I am Srinivaslu A from Sai Vidya Institute of Technology. I would like to thank SMARTCOM to provide an opportunity to present my paper here, and I would like to thank my guide to support us. So let us start. Hope you are seeing my screen.
Yes, sir, it is perfectly visible. You can continue.
Thank you, sir. Sir, our topic is Android malware detection using machine learning techniques. So here is a small introduction about Android. Android is the most widely used mobile operating system in the world. Millions of applicants are available for the usage. As as there is an increase in Android usage, so security threats are increasing rapidly as well. Because of this, Android devices have become a major target for malware attackers. Here comes a problem statement. Uh, with the increase in number of Android application, malware attacks have become more sophisticated, rendering traditional detection sorry, rendering traditional detection mechanisms are less efficient. Suggestion-based detection struggles with zero-day malware and obvious attacks. This is the challenge for developing an efficient, scalable, and intelligent system that can provide efficient malware detection and basic use of machine learning technique. Our main objective is uh, overcoming the zero-day and obvious malware attacks, detect, detecting malware for more accuracy, reduce fault alarms. To overcome this, we are using machine learning basic detection systems, databases. In our work, we use well-known Android malware detection databases that are Derbin, Malinonom, Malindrome 2020. These are the databases that contain both malware and Benjin Android application. Benin is nothing but safe applications. Feature use. We focus on static features such as permissions, API calls, manifest data. Here we use permissions like video, audio, storage data, this kind of permissions for API applications to match whether a app is using the permissions in a real manner or trying to collect different malware data to attack the system. Here comes a system architecture. Android application dataset. Here we load a dataset to train the model, and we apply FP growth algorithm on dataset, on Derbin dataset, for example. We found a high accuracy frequency of 150 combining in the dataset. Here we found that many applications ask for permissions like storage, security, applications, everything. So we converted this data permissions into binary language. Like if application is asking for a permission, we will value it as one. If not, we value it as zero. We'll store and collect all the data and store in the form of Excel, and we apply coexistence and store it. Once a user uploads a APK file, dataset which we have trained is active here, and I try to identify whether the APK file has malware or not. If the APK application is demanding or asking for any unknown pattern of permissions, that means there is a malware detection. So it is treated as malware detected. If not, it shows benzene. This is how our system works. Here is a simple proposal of our methods. We extract features from Android applications. First, we extract features from Android applications. Then we identify coexistence pattern frequency, meaning, for example, as I said, we search for similar patterns and permissions that are matching. If not matching, that is treated as uh, malware. Finally, this this feature are given as input machines learning models to classify the output or result. The most we trained and tested the multiple models include decision tree, random force, K-near, negotiable, support vector machine, XGBoost. Among this, we found XGBoost performing the best. Uh, in our testing, we found XGBoost producing the most accurate result with 98%. So most of the APKs are tested using XGBoost in our work. Overall result, XGBoost achieves the highest performance. The the module reached an accuracy of 98.7%. False, false positive rate were very low. This provides the efficiency of feature coexistent analysis. Advantages of our model. We overcome the low accuracy and our model produces the high accuracy, detects, prevents unseen malware, is scalable and reliable for the future use. Conclusion. Overall, overall we improved detection, malware accuracy, and coexistence significance, improved Android malware detection. Machine learning model, especially XGBoost, outperforms the traditional applications and provides robust performance. Future work, what we can implement is in the future dynamic and hybrid analysis using deep learning techniques and real-time integration and cloud updates. Here we can integrate a cloud system so that there is no requirement of hardware devices to identify any malware and improves real-time malware detection. Thank you, sir. I'm open for questions.
Thank you. Good presentation. Actually, I had three questions, but two of them you have answered in your presentation. So there's one question left that have you done any comparison with other techniques, already existing techniques in the market, with comparison to your technique? And if yes, then what were the results? I will love to know about that.
Sir, we tested with the old traditional methods and we overcome and we increased the accuracy and we overcame the 0 day and obvious malware detection system, sir.
Okay. So let's move to the next presentation.
Thank you.
Thank you.
Thank you, sir.
For the next presentation, I like to call Navmi Joshi for the paper title Application of Artificial Intelligence for Sustainable Biomedical Waste Management. I request the presenter to kindly proceed with their presentation.
Good afternoon, everyone. Am I audible?
Yes, ma'am, you're clearly audible.
I'll be sharing my PPT.
Oh, thank you, ma'am.
A very good afternoon to everyone. The title, my name is Navmi Joshi. I will be presenting the paper. Title is Application of Artificial Intelligence for Sustainable Biomedical Waste Management. The co-authors of the paper are Devesh Chauhan and Dr. Sunil Kumar, ICFI Law School, ICFI University, Dehradun. I'll be starting with the introduction of the paper. The paper basically revolves around how the AI can be used in the biomedical waste management, not the whole waste management system we are talking about. Only we are taking the subcategory of the waste management, that is biomedical waste. What is a biomedical waste? A biomedical waste is any waste which is generated during the we can say treatment, diagnosis, immunization of the humans and the animals, as well as even during the research activities which are conducted. So basically this is all, it is considered under the waste, the hazardous and very infectious waste. So after the post covid surge, we have seen there is a in the data wise, if we see that after the covid-19, the management of this waste is very important aspects in every country at the global level, we can say. Traditional systems, as particularly if we talk about at national level India. So in India, the basically the traditional systems are followed, the manual, and they're quite inefficient and unsafe, we can see that. So the main aim of the paper, the whole paper revolves around that how the AI can be included for the management of this biomedical waste. As AI, the artificial intelligence can help to transform this management, the BMW management system, when we combine it with machine learning, sensors, predictive analysis, and technology. Basically, in short, it improves the waste sorting, tracking, and disposal, and the final treatment of the waste. Indirectly, if we do the proper management of the waste with the help of AI, we improve the efficiency and everything. So basically, indirectly, it will help us for the to protect the environment, and as well as to the public health. It promotes very sustainable and cost effective healthcare management, we can say. So moving on to the next slides, we will talking about of some of the legal frameworks which talk about the BMW waste, and some of the we can say the international laws which talks about the hazardous waste and AI protocols, we can say. The biomedical in India, there is one proper, we can say, a guideline of protocol which works on this biomedical waste rule, that is 2016 India. These are some of the guidelines which all the healthcare institutions have to follow. How the color code, that there should be color code. It starts from the segregation till the treatment, starting from the segregation, distribution, last till the disposal and treatment of that waste. After the amendments, there are some of the things which were added in this legal framework, that the clinics and blood banks were also included, that they also have to follow the guidelines of the BMW rules 2016. In the global level, we have seen that only the Basel conventions, and there are some of the WHO guidelines which talks about that how the hazardous waste, and they don't directly talk about the biomedical waste, but they indirectly talk about that how the hazardous waste should be regulated and should be handled, we can say. And the AI, when we talk about the AI legal frameworks, there is a European conventions, and basically we can see that at the Indian level, when we talk about the biomedical waste rules, the AI, we don't have any direct law which talks about the direct implications of AI in the biomedical waste management. So the role of artificial intelligence in BMW. In the next slide, we will be talking about that how the AI can help the BMW management, starting from the segregation. Whenever we talk about the management of any BMW waste, we start with the segregation of the waste. So AI can help with the automated waste segregations, starting from the dustbins, then the real-time monitoring, while eye-to-eye predictive analysis for the collection and scheduling of the waste. Predictive analysis, we can say that in the healthcare sectors, we decide that how the how much amount of waste would be collected from which particular hospital is decided on the number of beds in the particular healthcare sector, and even the number of patients visiting at that particular. So the predictive analysis can help predicting on analysis of the number of beds and how much waste can be generated, and how we can schedule such treatment of such waste, and everything which we can do the predictive analysis, robotic handling of hazardous material, legal compliance, and digital tracking. In short, we can say that with the help of AI, we are just reducing the human exposure to the biomedical waste. We are just safeguarding the diseases which are spreaded, the infectious diseases, and which are transmitted, because the waste handlers are very much prone to, because they are the only one which are too much prone to the diseases or transmission, which is which happened after, if the waste is not managed properly. So basically, with the help of AI, we are also protecting the public health, especially the waste handlers and the sanitation staff, we can say. Moving on to the next slide, the why AI is important. We are talking about AI, but why it is important, why we need AI in the BMW waste management. It, in short, it improved the efficiency and accuracy. When we talk about the segregation, the data, the tons of waste generated, everything, there is a pollution control boards, state pollution control boards, central pollution control boards, so that the accuracy of the data they would be keeping with them, the waste generation data and everything, there can be an accuracy in keeping that data. It enhances safety. Safety of the healthcare workers, safety of the sanitation staff, and everybody who is indirectly connected with the management, BMW management, the safety of all that people, environmental sustainability, environment, because why we are connecting this thing with the environment, because if the BMW is not managed properly, we have seen that there is a high chance of having the contagious diseases and the transmission of diseases. We can say the BMW waste as it is like a lot of diseases, like uncountable number of diseases, as we think about, can be happened if it is not decomposed of properly. Better legal compliance. So basically AI is very important because the data would be very accurate if so legal compliance would be good. Like we have BMW waste, right? We have the very strong regulation, but the implementation of such regulation. So if we use AI, so the implementation of such policies which are given, the guideline which are provided in the BMW management 2016, the compliance of such guideline would be very would be in a very efficient way. They would be like compliance of such legal is very nice. Advantages, in short, the advantages, there are number of advantages, like there will be environmental advantages, pollution, water, air and soil pollutions, promote recycling and resource recovery, it also indirectly connect the SDGs, which we talk about, lower carbon emissions, reduce manual and operational benefits are, as we talk about in the guidelines, from the segregation till the disposal of that whole treatment of that BMW waste. It reduces the manual errors, the safety of healthcare workers, and same time and cost and efficiency would be increased. AI innovations, like some of the AI innovations which is suggested in the paper, is that number one, smart segregation system. Identify waste by image recognition. There are four kind of dustbin, like yellow, red, blue and white. So now the segregation is done manually with the waste handlers. If the AI is included in the healthcare sector, there can be a smart segregation of waste, that is identifying waste while image recognition. The waste would be recognized and we can segregate according to that in the particular dustbin. The predictive analysis, like how much waste would be generated from which hospital, the treatment and everything will be very sorted. Smart routing, the vehicle should be routed, the vehicles till they reach the common treatment plants, because if the hospital don't have their own BMW waste treatment plants, they have to be like disposed of to a common treatment waste treatment plants. There is a common waste treatment plants in every city or in every particular
Sorry to
districts.
interrupt, but you have 1 minute to conclude. Thank you.
Okay, okay, sir. And some of the legal alerts, like if there is non-compliance of such BMW race, there can be some AI innovations in that also, which can help with the legal, the case study. In the short, I have taken an example of the AIMS hospital. They are using an AI integrated smart bins in which they are using the RFID. This is radio frequency identification chips. They have these chips in the stickers, in the particular bags, in the different colors of bags, so they can track that from the hospital till the common treatment plants. The waste has been taken from the hospital to the from the operation theater to the disposed of sites. So they are using, many hospitals are even using the AI technology, and they have seen the efficiency and the incidents which are happening with the BMW. If the management is not done properly, so there can be more waste related incidents have like reduced, we can say. The recommendation is basically in short that AI should be included in the national waste laws, not the waste laws only, the even courts are including AI in proper courts also. So there should be in the waste laws, we can properly say that BMW waste laws or many other pollution control boards, or they should be adopting some AI technologies. AI generated data should be, but while we talk about AI, the AI ethics should be taken care of ethical, because the healthcare sector is a high risk sector. The data privacy and everything should be taken care of when we talk about AI in the healthcare sectors. And public and private cooperation, it is very important, because AI, when we talk about healthcare sectors, the training should be given of whenever somebody is using AI technology, we can say. So there should be a technologically advancement. When we want technologically advancement, the training should be given beforehand. So there should be a collaboration. And at the end, the conclusion is short, and that AI can help. This is a very conclusion that AI can help in a sustainable, safe, and smart healthcare waste management, we can say. It can reduce a lot of human health risk. Compliance would be there, and promote eco-friendly disposal. And but all of that, we can say that AI with the law and sustainability will help in having a clean green healthcare system, but keeping the ethics in mind when we apply AI in law, and especially in the high risk healthcare sector. Thank you so much.
Thank you, ma'am. I request our session chair, sir, do you have any questions? Okay, so let's move towards the next presentation. For the next presentation, I like to invite presenter Ruby Best for the paper title Determinants of Job Satisfaction Among Teachers, a comprehensive review of empirical evidence. I request the presenter to kindly proceed with their presentation. I request presenter to kindly proceed with their presentation.
Good afternoon, everyone. Sir, am I audible?
Yes, ma'am, you're perfectly audible and your screen is visible to us.
Okay. Good afternoon, everyone. My name is Ruby Bist, and I am presenting my research paper titled The Determinants of Job Satisfaction Among Teachers, a comprehensive review of empirical evidences. So I will start with my introduction and problem statements. As we all know that teacher plays a crucial role in shaping the society and the future workplace. The success of any education system depends largely on the motivation, commitment, and the well-being of the teachers. Job satisfaction is therefore a key factor influencing teacher performance, retention, and professional sustainability. However, today teachers faces increasing workload, competition, and stress are affecting teachers' morale. So existing research on teachers' job satisfaction is fragmented and context specific. So, although many studies have examined teachers' job satisfaction, the findings remain scattered across the different sectors. But this paper presents a comprehensive review of empirical evidences to identify the key determinants of job satisfaction and suggest some strategic directions for improvement of the teachers' job satisfaction. Literature review. So previous studies shows that teachers are generally satisfied with their works and supervision, but dissatisfied with their pay and promotion. Gender differences exist in job satisfaction across the profession in different countries. Some researchers said that psychological factors such as stress, burnout, self-efficacy, emotional exhaustion strongly influence the job satisfaction. Workplace environment and the school climate are the major predictors of job satisfaction among the teachers. So work-life balance is also a significant factor that predicts job satisfaction and reduces the turnover intention. So research studies
Ma'am,
further
your
confirm.
screen
Hello.
is stuck on the first slide. Can you please change the slides?
Okay, sir. 1 second.
Yes, ma'am.
Sir,
Now it is
is it
visible.
visible now?
Yes, ma'am. Please continue.
Okay. So the recent studies further confirm that the work-life balance is a strong predictor of job satisfaction and employee retention. Researches on the school teachers' job satisfaction remain fragmented and lacked integrated perspective. Objective. To understand the teacher's job satisfaction, this review draws on multiple theoretical perspectives. The main objective of my papers are to identify the key determinants of job satisfaction among teachers, to review the empirical study on teachers' job satisfaction across different countries and educational contexts, to provide strategic recommendations for improving teachers' job satisfaction. So the first theory was Hertzberg two-factor theory that explains the difference between intrinsic motivators such as achievement and recognitions and the extrinsic hygiene factors such as salary and working condition of the employees. Next theory was Maslow's hierarchy theory that explains the satisfaction through the different level of needs of any human being, that starts with the physiological needs, safety, social needs, esteem needs, and ends with the self-actualization needs. The next theory was job characteristics model that highlights the role of autonomy and the task significance and feedback, while the theory of work adjustment focuses on the person and environment fit and its impact on the job satisfaction. And last theory was social exchange theory that emphasizes the importance of organizational support and its impact on the positive workplace relationship. Methodology. This study adopts a comprehensive review approach by analyzing the peer-reviewed empirical studies on teachers' job satisfaction across the different countries and sectors. The review focuses on the organizational, personal, and work-related factors that influence the job satisfaction, but theoretical and empirical evidences were synthesized to identify key determinants and develop a strategical recommendation. Key determinants of job satisfaction. The review identifies three broad categories of the determinants that influence the teacher's job satisfaction. First category was organizational factors, second was personal factors, and third one was job-related factors. So organizational factors includes compensation, working condition, leadership, school climate, and promotion opportunities that influence the job satisfaction of teacher. Next one was personal factors. Personal factors include such as emotional exhaustions, age, gender, experience, motivation, and career identity that also plays a crucial role in the teacher's job satisfaction. Last was job-related factors. These factors includes workload, administrative responsibilities, autonomy, and personal freedom, and the nature of teaching work. All these determinants interact to shape the teacher's overall performance and personal well-being. All these factors together influence the teacher's job satisfaction. Key findings from the literature. The literature reveals that the compensation and promotion opportunities remain strong predictors of job satisfaction among the teachers. Emotional exhaustion and the burnout reduces the job satisfaction where the supportive school climate and the positive motivation from the leadership enhance their commitment. Several recent studies also show that work-life balance is a strong predictor of job satisfaction among the teachers. Psychological resources such as self-efficacy, resilience further contribute to the personal sustainability. Results and discussion. The literature shows that teacher job satisfaction is influenced by the combination of intrinsic and extrinsic factors. Organizational environment, leadership practices, and working conditions plays a central role in the shaping teacher well-being. At the same time, excessive workload and administrative pressure reduce the professional satisfaction. Psychological resources such as resilience and the self-efficacy strengthen the motivation, while work-life balance emerges as a key factor that plays a mediating role, linking work demands to overall job satisfaction. Policy and practical implications. The findings of this paper suggest that improving teachers' job satisfaction requires coordinated efforts from the school administrators, policymakers, and educational authorities. A fair compensation and transparent promotion policies are essential to support their job satisfaction. Supportive leadership and the positive workplace uh, managing supportive leadership and the positive school climate can significantly enhance teacher motivation. Managing workload and reducing administrative burden are crucial for preventing their burnout. Additionally, promoting work-life balance and providing continuous professional development can strengthen their teacher well-being and long-term professional commitment. Future directions. Although the existing studies provide valuable insight into the teacher job satisfaction, several research gap remains. The future research should focus on the cross-country comparative studies and longitudinal designs to capture the changes over the time. Greater attention is needed on the cultural and the policy context, as well as the role of work-life balance in shaping the job satisfaction of teachers. Mixed methods approaches would further enhance the depth and practical relevance of future investigation. In conclusion, teacher job satisfaction is a critical determinant of education quality and long-term sustainability. The evidence shows that both intrinsic and extrinsic factors influence the professional well-being, with organizational support and leadership playing a central role. Work-life balance further strengthens the motivation and professional commitment. Therefore, improving the teacher well-being is not only beneficial for educators, but also essential for the building resilient and effective education systems. Thank you.
One of the prominent subjects to be talked about. I only have one question that in the title that you have mentioned, it's a comprehensive review of empirical evidence. So, have you included any kind of real data or experimentation in this project?
Sir, I have included the studies, previous studies that are from the empirical studies and the literature studies.
Mm-hmm. Okay, perfect. Now we will be moving towards the next presentation.
Thank you.
Thank you, ma'am. For the next presentation, I like to call presenter GP Kawali for the paper title IoT-based intelligent vehicle lockout and real-time alert system. I request the presenter to kindly proceed with their presentation.
Thank you, sir. Am I audible?
Yes, sir, you're clearly audible to us.
Sir, I'm not able to share my screen. I don't know why, because the share button is showing disabled to me.
Let me check, sir. Give me a second. No, sir, it is enabled for everyone. You can share it.
But it is showing disabled on my screen, sir. I don't know why it is showing.
Now check, sir.
No, sir. It is still showing disabled.
Can you please rejoin the meeting? I think so that will.
Yes, sir.
Uh,
Within a second. Just.
yeah, perfect.
Yes, it is enabled now, sir.
So please proceed.
Okay, sir. So is my screen visible?
Yes, sir. Your screen is visible to us.
Okay, thank you so much, sir. So, good afternoon, everyone present here, and I would like to thank SmartCom 2026 team for giving me this opportunity to present my work titled IoT-based intelligent vehicle lockout and real-time alert system. My paper ID is 493, and so these are the contents of my presentation. So we will start from the introduction. So nowadays, road safety is a critical global challenge affecting all age groups. Among the various causes, underage driving and alcohol impaired driving remain major contributions to fatal road accidents. Most existing vehicle safety solutions are reactive. It means they respond after a violation or accident occurred. So preventing unsafe driving before vehicle ignition is still under export. Uh, with the emergence of Internet of Things, it is now possible to combine real world sensing, local decision making, and accountability. So our work explores how biometrics, embedded systems, and IoT can be integrated to enforce legal eligibility and sobriety at the point of vehicle access. So globally, road accidents cause approximately 1.19 million deaths every year. So, in India alone, more than 168,000 fatalities were reported in the 2023. Two major contributing factors are underage driving, alcohol impaired driving. So these two are the important factors that are causing mostly the road accidents. So existing systems typically verify identity or sobriety in isolation. So there is no integrated system. So they lack eligibility enforcement and provide poor stakeholder alerting. Hence, there is a clear need for a preventive automated enforce before ignition safety system. So this is the motivation of our work. So we have identified a research gap from the literature review, and we have identified these three main key gaps. First one is biometric systems authenticate identity but do not enforce legal age eligibility and lack integration with alcohol impaired checks. The second gap we have identified is the alcohol interlock devices detect intoxication but operate as standalone systems without identity verification, legal eligibility checks, or real-time alerting. And the third one, IoT-based vehicle safety systems focuses mainly on monitoring and post-event reporting, often depending on network connectivity. So therefore, no unified solution exists that combines biometric age verification for underage driver restriction, alcohol detection, and real-time accountability together. So these are our key contributions. So the key contribution of this work are: first, a fingerprint based underage restriction mechanism implementing biometric age eligibility enforcement using date of birth encoded identity profiles. Second, a sequential access enforcement model following the chain identity, age, sobriety, and ignition. Then third one, the local deterministic lockout ensuring no cloud dependency for safety enforcement. The next one is real-time IoT alerts using geotag SMS via the SIM7600 EI module. Finally, the system is validated through working hardware prototype. Then this is our system overview. Our system follows the security by design IoT architecture principle. All safety enforcement is performed inside the vehicle using a fail-fast decision chain. The design is privacy aware, low cost, and suitable for retrofit ready deployment. Then ignition enabled only if the driver is legally eligible, meaning he is not underage and the driver is sober. This is the system layered architecture. So in which, as we can see, the layer 1 consists of user input sensors like R307S fingerprint sensor and the MQ3 alcohol sensor. The layer 2 handles processing and decision making. It compresses with the Raspberry Pi 5, performs biometric matching and manages the encrypted eligibility database. The Arduino Mega 2560 executes thresholding and fail-fast control logic. As we can see, the layer 3 enforcement layer, which performs enforcement through ignition, disable delays, and an in-cabin buzzer alerts. And the layer 4 connectivity layer, which provides IoT connectivity using the SIM7600 EI 4G GNSS module, which is used for geotag SMS alerts. So then the biometric underage restriction module. In the first enforcement stage, the driver's fingerprint is captured using the R307S sensors, and authentication request is sent to the Raspberry Pi, which maintains a locally encrypted SQLite database containing fingerprint IDs, date of birth, and license metadata. The driver's age is evaluated dynamically at authentication time. If the driver is underage, ignition is immediately disabled and an alert is triggered. This converts biometrics into the legal access enforcement, not just the authentication. The second module, alcohol detection module. After successful age verification, the system performs alcohol detection. The MQ3 ethanol sensor uses calibrated threshold based detection with median filtering to reduce false positives. Alcohol detection is executed only after biometric validation. If alcohol concentration exceeds the threshold, ignition is disabled even for authorized users. This ensures intoxicated driving is prevented proactively. So this is the operational flow of our system. So as we can see, the system first, after power on, it checks for the fingerprint and then verifies the age of driver. If the driver is eligible, means he is above the age limit. So if he is below the age limit, the ignition will be, the engine will be lockout, and the buzzer will create an alarm sound, and the SMS with the geotagged information will be sent to the stakeholder's mobile number. Then after the first stage is passed, the system goes to the second stage, that is the alcohol checking. And similarly, if the driver is drunken, the system will be lockout and will buzzer and send the SMS to the stakeholder. Otherwise, the system will be normally start the ignition. Only both conditions are satisfied. Then the hardware prototype is compresses. We have implemented working prototype using the low cost hardware component. This includes Arduino Mega, Raspberry Pi, and so on. Then the IoT alerting mechanism, the system uses event driven SMS alerts triggered only during the violation. Each alert includes violation type, timestamp, GPS coordinates with Google Maps links. The average delivery time is approximately 0.9 seconds, and no continuous tracking is
Sorry to
performed,
interrupt, sir,
ensuring
but you
prevention.
have 1 minute to conclude.
Yes, sir. Okay. So this is the experimental evaluation. So I would like to show the result accuracies. So these are our results. So the biometric age verification module achieved 97.8% accuracy, while the alcohol detection module achieved 96.4% sensitivity and the 95.7% specificity. Then the result latencies, biometric matching required approximately 1.2 seconds, while alcohol detection required 1.8 seconds. So decision processing time was between 2.7 and 3.1 seconds. The MQ3 sensor warm up time was about 20 seconds, which is included in practical deployment. And the SMS dispatch time latency was the 0.9 seconds, so meeting real-time safety requirements. So the comparative analysis was the biometric only systems, no age and sobriety checks, alcohol interlock, standalone intoxication detection, no identity or eligibility enforcement, and so on. So the system meets the security and privacy because the system locally enforces and no cloud dependency, encrypted biometric storage, minimal data exposure, event level alerts only, reduce attack surfaces, and the design with the security by design principles. So limitations, these are some limitations. MQ3 requires a warm-up time, then it is environmental sensitive, and prototype scale deployment, etc. are the then future enhancements, though sensor fusion, canvas integration, like these are the future enhancements. So in conclusion, the system successfully prevents underage driving, alcohol impaired driving, then enforces safety before ignitions, and combines biometric, IoT, and local administrative controls. It is a low-cost, scalable, and privacy-aware, a practical step towards safer, intelligent transportation systems. So these are some references that we have used in our work. So thank you so much.
Thank you, sir. I only have one question that can you please define how you are verifying the age again?
Sir, actually, I have created a simulated database which is handled by the Raspberry Pi. And when my fingerprint sensor requests to the Raspberry Pi to verify as the user puts fingerprint on the sensor, and it is checked against the database that is the driver is
That's
above
understood.
18 years or yes, sir. Okay.
Now, my question is, there are a lot of people on this earth, no? So how will we handle this massive population as it will increase the size of
Yeah.
the database and time to
Yes, right, sir. Right,
check that out,
right,
no?
sir. Actually, the future enhancement is what we can link it to the government databases, sir. Like we have to take the prior permissions from that, or for that we can use the RTO database, or we can extend it to the Aadhaar database for the verification, sir.
That was actually my suggestion that you can try for Aadhaar authentication or
Yes, sir. Right,
vehicle
right.
verified. Yeah,
Thank you so
wonderful.
much for the suggestion, sir.
Yeah, it's wonderful. Changing your actions from reactive stage to precautions, it's wonderful.
Precautions, right, right, sir. Thank you so much, sir.
Now we will be moving forward for the next presentation. For the next presentation, I like to call the presenter Zuli for the paper title ResNet 50 Driven Facial Skin Type Analysis for Dermatological Assessment. I request the presenter to kindly proceed with their presentation.
Good afternoon, everyone. Am I audible?
Yes, ma'am, you're audible and your screen is visible. Please continue.
Okay. I am Zuli Dobaria, and today I will be presenting our work titled ResNet 50 Driven Facial Type Analysis for Dermatological Assessment. This work focuses on using deep learning to automatically classify facial skin types with the goal of supporting personalized skincare applications. This is the agenda that I will be presenting in my presentation step by step. So nowadays, personalized skincare is becoming increasingly important as a different skin types require different treatments. Manual skin analysis often subjective, time consuming and require expert consultation To address this, we explore an automated deep learning based solution. Skin type classification, specifically for oily, normal, and dry skin, is essential for selecting appropriate skin type or skincare products. With advance in deep learning and image processing, it has become possible to automatically identify the skin type of facial images. However, there are lots of traditional CNN architectures often suffer from the degradation and vanishing gradient problems. As to overcome that issue, the study motivate us to use of ResNet 50, which introduces residual net connections to address this issue and limitations has been explored for facial skin type classification. The core research problem is to accurately and automatically classify facial skin images into normal, dry, and oily categories of facial images. Our objectives are uh, objectives are threefold. First, to develop a ResNet 50 based automated skin type classification system. Second, to improve classification accuracy using transfer learning and fine tuning. And third, to compare its performance with another models such as ResNet 18 and ResNet 34 and many traditional CNN models. Uh, Earlier studies have used CNN based approach for skin type classification, but these models are often limited in depth and generalization capabilities. Residual networks or ResNet address this issue by introducing short connections which help to prevent vanishing gradients and allow deeper architecture to trend effectively. ResNet based models have demonstrated superior performance compared to VGG and AlexNet in various image classification tasks. Additionally, there are prior works that shows the automated skin classification can support dermatological assessment and personalized skincare applications. These findings motivate our choice of ResNet 50 as the backbone for this study. This is the workflow of our workflow that we created for our model. That first it start with the data set followed by the data augmentation, feature extraction using ResNet 50, fine tuning and testing the data set and getting the result. I will be now explain how each their stage was implemented in practice. Dataset and pre-processing and augmentation steps. We used a publicly available facial image dataset containing three skin types: dry, normal, and oily. The dataset was split into 80% of training, 10% of validation, and 10% of testing data. All images were resized and normalized to match the ResNet 50 input requirements. To improve robustness and generalization, we applied data augmentation techniques such as random cropping from 224 to 2 by 224, rotation up to plus or minus 30 degree, and horizontal and vertical flipping and variation in brightness and color. Since the dataset was slightly imbalanced, we used class weighted training so that classes were not biased during learning. We applied transfer learning using pre-trained ResNet 50 model. The model was fine-tuned using stochastic gradient descent with a batch size of 32 and learning rate of 0.1. Performance was evaluated using multiple metrics, including accuracy conclusion metrics, precision recall, and F1 score. ResNet 50 outperformed both ResNet 18 and ResNet 34. The training accuracy was 89.79%, validation accuracy of 39.84%, and the testing accuracy of 95.29% we achieved. These results indicate strong generalization and robustness of the proposed results. Confusion matrix shows the balanced classification across all the skin types. The accuracy and loss curves indicate stable convergence without significant overfitting. High precision and recall values confirm that a ResNet 50 effectively extract facial features from the skin type classification. These are some applications that we can use from using this model, that we can use it for automated dermatological skin type analysis, personalized skincare recommendation system, and particularly integrate it into the mobile and web-based healthcare platforms so that we can easily classify our skin types. These are the limitation of this work, that images are collected in controlled environment, and it is limited in real world variability, as we have already check it and outline all the features that we can get real time results, and in the real light it perfectly work very widely, but in some cases it doesn't work well. In the future work, we would like to get more diverse data so that we can explore it in more, and incorporate with different techniques such as grade chem to avoid the lighting problems, and we would like to enhance our recommendation system for the natural ingredients, that dermatological curated data from that we can manage to provide the users natural products, and we need to find the data set for that. To conclude, we developed a ResNet 50 based facial skin type classification system that achieved 95.29% testing accuracy, and that outperforming the traditional CNN methods. The results demonstrate the effectiveness of deep learning for dermatological assessment and provide a strong foundation for future intelligent skincare recommendation systems. These are the references for this study. Thank you for your attention. I will be happy to take any questions.
Only one question, ma'am. The thing is, have you considered any other models other than CNN on ResNet for this study? And have you performed the ablation study on ResNet model? Only this question, please.
Yes, we have explored CNN, ResNet, and other models, but we did not get a much accuracy and did not get a proper solution for the classification.
Okay, perfect. Now we will be moving towards next presentation. For the next presentation, I like to invite presenter Dhruvika Singh for the paper titled Smart Grid and Renewable Energy Adoption as Drivers of Sustainable Performance, the Role of Environmental Awareness and Attitude Towards Sustainability. I request the presenter to kindly proceed with their presentation.
Thank you so much, sir.
I request the presenter to kindly proceed with their presentation.
Sir, just wait a second. I'm trying to share my screen.
No problem, ma'am.
Sir, is it visible?
Yes, ma'am, it is visible, but we are able to see your browser screen, not the presentation.
Okay, sir. Sir, now is it visible?
Ma'am, it's loading on my screen.
Is it visible?
It's still loading. Ma'am, you can continue with the presentation. No problem with that. Yeah, ma'am, now it is visible. You can continue.
Okay, sir. Okay. Good afternoon, everyone. Myself, Dhruvika Singh. Today, I am presenting my study and renewable energy adoption as driver of sustainable performance, the role of environmental awareness and attitude towards sustainability. This work is a bibliometric analysis that explores how technological innovation and human behavior together contribute to sustainable energy system. Overview of the study is the study conducted a bibliometric analysis of global research grid, renewable energy adoption, and sustainable performance. We analyzed 183 Scopus publication from 2011 to 2025 using BiblioShiny and WOSPHERE. The findings show a 36.46 46% annual growth rate, highlighting the increasing on intelligent and clean energy system. Strong international collaboration and interdisciplinary research trends were also observed. Introduction of the global energy systems are undergoing a major transformation due to rising energy demand and climate change concern. Smart grid enhances energy efficiency and reliability while renewable energy reduces carbon emissions. However, technological solutions alone are
Ma'am,
not
we are only
sufficient.
able to see your full screen, your first slide of the
Uh,
presentation. Please switch.
I think network issue. So,
Okay, no problem, ma'am. You can continue.
okay, sir. However, technological solutions alone are not sufficient. Environmental awareness and positive attitude towards sustainability play a critical role in increasing clean energy adoption. This study examines how technology and human behavior jointly drive sustainable performance. Need for this study. Although significant research exists on smart grid and renewable energy related studies, integrate technological innovation with behavioral aspects such as environmental awareness. Understanding this combined impact is essential for achieving long-term sustainability goals. This gap motivates diplomatic investigation. The objective of this study to analyze publications in smart grid and renewable energy research, to identify leading journal author, institutions, and countries, to examine key research themes and emerging keywords, to access the role of environmental awareness and sustainability attitudes, to map conceptual and collaborative research network. We use the Scopus database as our data source, covering publications from 2011 to 2025. The dataset includes 183 research articles, review and conference papers. A systematic literature review and a bibliometric analysis approach was adopted. Hello.
Yes, ma'am, you're audible. You can continue from where you have left.
Oh, okay, sir. Okay, sir. For analysis, we applied BiblioShiny and WasViewer. These tools help to generate publication trends, keyword co-occurrence networks, collaboration maps, and source impact analysis. This ensured both quantitative and visual interpretation of research pattern. The result indicate a steady and significant increase in publication over time. The annual growth rate is 36.46%, reflect the accelerating interest in smart grid and renewable energy as sustainability solutions. These trends align with global climate and clean energy policies. Keywords analysis revealed major thematic clusters around sustainability, renewable energy adoption, green energy, circular economy, and carbon reduction. This results shows a strong interlinkage between technology, environmental policy, and behavioral science. In terms of geographical contribution, China leads the research output, followed by the United Kingdom and India. Emerging contribution from countries like Italy and Bangladesh highlight growing global participation in sustainability research. The journal Sustainability Switzerland ranks as the most influential source in this field. Other prominent journals include Discover Sustainability and Sustainable Futures. This indicates a strong interdisciplinary publication landscape. Collaboration, Collaborative research network. Our analysis identifies 691 authors with an international co-authorship rate of nearly 35%. This demonstrates strong global collaboration and knowledge sharing across institutions and countries. Smart grid and renewable energy adoption offers several advantages including improved energy efficiency, enhanced grid reliability, reduced carbon emissions, and increased consumer participation through smart technologies. Limitations of my study: despite these benefits, these include high infrastructure cost, cybersecurity risk, technological complexity, regulatory gaps, and limited public awareness. Future advancements include the integration of AI, blockchain, and energy storage system, development of decentralization and community-based grid, and stronger policies focusing on consumer education and behavioral research. The findings highlight that technological innovation alone cannot ensure sustainability. Environmental awareness and positive attitudes towards sustainability significantly enhance the effectiveness of smart grid and renewable energy system. In conclusion, this bibliometric study confirms a growing global focus on smart grid and renewable energy as drivers of sustainable performance. The integration of advanced technologies with pro-environmental behavior is essential for achieving long-term sustainability goals. Thank you, sir.
Thank you, ma'am. It's a wonderful presentation on a very crucial topic and a novel work. Thank you. Now we'll be moving towards the next presentation. For the next presentation, I like to call presenter Aditya for the paper title Subtitle Translation and Back Translation Validation Using Neural Machine Translation. I request the presenter to kindly proceed with their presentation.
Thank you. Am I audible?
Yes, sir, you are audible to us.
Yeah, I'll just start presenting. Uh, Okay. Can you see my screen?
Yes, sir, your screen is visible to us. You can proceed.
Okay. Yeah, thank you. So I'll start. So good afternoon, everyone. My name is Aditya Bhabal, and today I'm going to present our paper on subtitle translation and back translation validation using neural machine translation. So basically, in today's growing trend of online content that is available like Netflix, Amazon Prime Video, and so on, subtitle translation has become a crucial point of accessibility for people who do not speak certain languages. So, with the explosion of global streaming content, there is also a need for uh, accurate as well as high fidelity translation of certain like content that is available on the platforms. So when it comes to subtitles in any like if we say movie or shows, then it must satisfy three constraints upon translation. That is linguistic accuracy, which means that it should be correct, like linguistically correct in the other language in which it is being translated. It should have a high semantic fidelity, meaning that it is clear, like it is not. It should make sense when it is translated, and readability and timing, which means that for certain scenes, whichever scene is being played on the screen, the subtitle should match that, and it should not leak over into the next scene, creating confusions. So the current systems that exist have certain limitations. These are that they focus on only on translation accuracy, and they do not consider reading speed, that is character per second constraints, and as a result they are often like either inaccurate or they are not consistent with the scenes. So the motivation, like I said, is this. Sorry. Yeah. So the key contributions in this that we have done is basically it provides an end-to-end pipeline for translating subtitles. It utilizes Helsinki's Marian MT, which is basically a lighter version of a machine translation that we have used. And then it utilizes back translation. That is, it translates into the other language and then also back translates it and checks the similarity between the original and the translated script using SBERT for checking if the translated subtitle is accurate. It also considers characters per second while generating the translations, and generates in both .srt files, which are basically special type of files which can be fed directly into most video player applications, so as to generate uh, display subtitles based on the timestamps that are given in that file. It also generates a JSON quality report, which gives basically an overview of the translation quality that we have achieved upon performing the translation. Then certain other works that have existed, which have like done research into this. Uh, it ha it first one is the first one evaluates the timing, segmentation, and the edit distance for the subtitle translations. The problem with this is that it is only based on the metrics, and it does not give a complete end-to-end pipeline for translating subtitles or any text basically. So end-to-end automatic subtitling. In this, they are direct speech translation modules. That is, they consider the speech of the videos and then they translate in real time. However, this is slightly high computational cost because it has to continuously generate the subtitles. So basically, it is like a live stream of the subtitles. LLM based models and context aware systems, in this they are adaptive since they're using LLM prompts, but this is also a limitation because it locks it to the quality of the prompt that is being supplied to the LLM. So uh, it can be quite difficult in this scenario if like the prompt is not properly shaped or like properly phrased. So ASR and readability focused systems, they perform the character per second based readability checks, and they also like give generated subtitles. The limitation is that it is mostly interlingual, and it does not give a definitive translation validation, like how the quality of the translation that has been generated. So basically, this is the system design that we have implemented. So the pipeline starts with providing the SRT file to the front end. So after we get that, we process it for like translation, and we also generate a back translation simultaneously in a pipelined manner, so that there is no high computational costs. We use Marian MT for both. The back translation has had to be made optional because doing both at the same time could be time consuming, especially on a CPU based system where GPU acceleration is not available. So we also added an SBOT based semantic similarity system where we compare the original text with the back translation to find out exactly how good the translation quality was. There is also the readability check that is being performed before before the translation happens, and then we the sub mm, give out the SRT and JSON output. So basically, why we utilize Marian MT was because, first of all, biggest reason was its efficiency on CPU. It provides translations quicker and without requiring GPU acceleration. It also has very strong multilingual support with like high resource languages being English, Spanish, French, and so on. uh, it does not require any specific fine tuning. It is quite capable on its own, unless it is deployed on something that is very for example, very low resource languages like certain Native American languages, or certain Indian languages that are not supported by Marian MT. So to further speed up the process of the translation, we implemented batch translation, beam search decoding, and we excluded sound cues, for example, music and applause and other sound cues that are present in the subtitles in, say, in movies. So we excluded the translation of those so as to prevent any confusion to the Marian MT. So the reason we performed back translation is because it acts as a way of checking semantic fidelity of the subtitles. So basically, it does not require any human intervention to like tell if the translation is accurate or not. So we also provided a semantic scoring system wherein we utilize cosine similarity, and you can set the threshold at any value, but generally 95% threshold is actually pretty enough to understand like whether they are accurate, or whether the subtitles are accurate or not. So the characters per second criteria that we added is basically it has this formula, characters per subtitle duration. So it basically in per scene it checks how many number of characters are being played per second, and it should fit within that time step. So it is basically a viewer comfort based criteria. So the industry recommended value is generally 20 to 25 characters per second, which we have implemented so as to maintain viewer comfort and accessibility. So the output that we generated is in translated SRT format, which we can directly plug into most media players so as to immediately use those files. We also generate the JSON quality report, like I said, which checks out the confidence score of the subtitles, the back translation similarity for each and every subtitle that is
Sorry to
generated.
interrupt, sir, but you have 1 minute to conclude.
Yeah, yeah. So as you can see, these are the JSON based reports that we have generated on a test corpus. These are some of the metrics that we have utilized for understanding the relationship between reading speed, semantic similarity, semantic fidelity, and back translation similarities. So in case you have some low similarity values, you can add that for manual review from, so you can introduce a human element into this in case the confidence, like low confidence subtitles, wherein there are like idioms or expressions that are specific to certain cultures and so on. Finally, I would like to say that these are the strengths, that the whole process is fully automated. So they are like language pair agnostic. They are quality aware subtitles. Basically, they include multiple criterias for generating the translations. Obviously, limitations are certain idiomatic expressions that cannot be identified by the Marian MT, and certain low resource languages are still not covered within that. So these are the takeaways. So these can be used for like streaming or education for multiple, like if we are using certain educational videos which in different languages, we can use that. Future work, we can obviously benefit from GPU acceleration, compressing the subtitles adaptively. We can also add that idiom aware translation, which we are not able to implement, and low resource language support we could definitely add. We could also integrate with like actual videos and dubbing pipelines that are present. So that's all. Thank you. Any questions? I'll be willing to take.
Only one question. Like, you have considered Marian MT for the paper, no?
Yeah.
So, have you compared any other MLT techniques other than this? If yes, then what were the results and what were the comparison that you have done? So that makes you choose the Marian MT.
Yeah, so the thing is, Marian MT is comparatively lightweight. The thing is, the whole aim was to be able to run it on a CPU device rather than going for GPU acceleration. So other models like MBART and there are a few other, like some are developed by Facebook. So these things are heavily resource intensive. Like they have several like a billion parameters or something like that. So the problem is whenever you try to run this, the time for generation automatically goes up because of the high amount of resources that it. So Marian MT actually produced decent results because while also maintaining that time constant. Like if for a 15-minute video that has like continuous talking in it and lots of subtitles, it will give out the translation, the simple forward translation in like 2 or 3 minutes with the CPU acceleration. So that was the reason.
Perfect. And as you have mentioned in future work that you will be working with GPUs and all, and currently you don't have access to GPUs, no?
I do, but the thing is more like if we are going for say educational videos or something like that,
Hmm.
and in like say low and we want to cut the costs, say, so like preserve that cost. So in that case, if GPU systems are not available, it should run on CPU. So that was a major consideration in making that.
Oh, perfect, perfect. Now we'll be moving towards the next presentation. For the next presentation, I like to call presenters Samruddhi Patil for the paper title Towards Reliable Brain Tumor Diagnosis, Understanding Deep Radiomic and Hybrid Feature Behavior on Fused CT MRI Data. I request the presenter to kindly proceed with their presentation.
Hello, everyone. Good morning. Good afternoon.
Good afternoon, ma'am. Now
I'll
you
be
can share
sharing
your.
my screen.
Yeah.
Is it visible?
Not yet, ma'am.
Okay. Yes, now?
Yes, ma'am. Please proceed.
Okay. So my paper title is as seen towards reliable brain tumor diagnosis and understanding the deep radiomic and hybrid feature behavior on the fused CT, M and MRI data. So my name is Samruddhi Patil and I'm from KL Engineering College. So to talk about the background of and the motivation for this study. Usually, what happens is my MRI is my primary imaging modality that's used for diagnosing brain tumor cases, right? But in some cases, as seen in my figure one, my CT will have complementary characteristics to MRI to determine or diagnose a tumor. So what my MRI does is that it provides me superior soft tissue contrast and like how much the tumor has infiltrated into the tissues. And what my CT is doing is that it is basically talking about the bone structure, how much it is distorted, if there is calcification in the lesions that are found on the brain. So in the figure one, we can see that it's an example of meningioma, where we have infiltration on the meninges of the brain, as seen in the MRI. But in case of CT, we can determine that okay, there is a calcification that can be seen and hyperosteosis, as we say, the thickening of the inner skull is seen. So these are complementary characteristics that help us diagnose. Another example would be oligodendroglioma. In this case, my MRI appears like a lesion, but with the help of CT, we confirm calcification that allows us to determine or differentiate it from another kind of brain tumor. So this is like a clear motivation for us to understand that okay, MRI and CT, both of them have complementary characteristics, and possibly taking both of these characteristics could help us diagnose the brain tumors better. So most often, the recent studies, they have mainly used the deep features extracted from the CNNs and the transformer models. We see very less studies that have comparison of what features extracted and how they have behaved. As in, some studies have extracted features from deep learning models, and some of them usually PET or like MRI based studies, they use radiomic features. So there's very less study as to comparison of the kind of features they have extracted and how it is impacting the MRI, the brain tumor classification. So the objectives of this study are very clear. We want to design a feature extraction pipelines that allow us to leverage both of these features from MRI and CT well for our classification, and to understand which features are. Our second objective would be to understand which features are behaving well in the classification, and to basically analyze how these features extracted are going to help us diagnose better, and why, and so on. So to talk about the data set that we are using, these are some of the data sources, links that as you can see. From all these three links, we have taken the MRI and CT slices of the same patients, and further pre-processed it. We can see we have done image registration. Now to talk about the image registration, we use your enhanced correlation algorithm. As to why, because usually what happens, CT and MRI are taken from different machines. So we can see that there might be some variance in anatomical geometry due to caused by different machines. So that's why we want to align them with the same geometry, with the same coordination. So that is why we are registering with the help of enhanced correlation algorithm, where basically the intensities of the pixels are correlated, and that's how they are aligned. Next, we see contrast enhancement. So as it says, a lot of times what happens is that these modalities have very low contrast, and we want to classify tumors. So the boundaries of these tumors become very important. Any sort of calcifications become very important to determine the infiltration or anything else, the hyperosteosis like that. So that's why we are doing contrast enhancement as well. Then to normalize any variance that has occurred in these images, we are doing Z-score normalization. From these, we get the MRI and CT pre-processed images. So these are some of the images from the data set. We can see note it's a binary data set where we have the tumor class and we have the no tumor class. So to talk about the overall overview of the experimental or the methodology. So we have the CT and MRI registered images. So there's fusion and fusion of these images that happen. In this study, we are not essentially analyzing the fusion mechanism that is there. We are mainly focused on comparison of the features that are extracted and how these features are going to help us perform better in diagnosing. So we have the fusion, and then we have the feature extraction that happens, and possibly feature concatenation that happens. We have three classifiers as seen here, and then we are evaluating them. So to talk about the classifier frameworks, we have the SVM model. It does handle high dimensional data and it is very good with non-linear feature distributions. And our data set is limited, so that's why SVM would work well. And then we have the random forest, which could be very helpful as it is better for avoiding overfitting. And we also see how these two classifiers together would be performing. Now to talk about the kind of feature extractors that we have. So we have in figure 4, you can see there's deep feature extractor. So we have three models there, deep learning models that will help us extract semantic features, meaningful features, structures, overall structures. And the next thing we have is the handcrafted features. Now handcrafted features would allow us to have extract certain things such as textures of certain areas or the contrast of the certain areas, the gradient and the intensity changes of the areas. So that's where our handcrafted feature extractor comes in. So as seen here, we have in the handcrafted features, we have the histogram oriented gradient, which allows us to capture the edges and the shape information. Where we have the local binary pattern that allows us to extract the texture patterns, and the spatial intensities of the relationship is also captured. Then next we have the deep learning model, where we have our SNet 18. Uh, so what it helps us to do is that it allows us to have low level textures and we have high level textures. All of this is quite preserved in my ResNet. So fine textures from the MRIs and the sharp structures from the CTs, both of them remain intact in this deep learning model. Whereas my efficient net, we can see that soft tissue textures, low contrast tumor cores. All of this is captured well in efficient net. We have convolution, mobile inverted bottleneck convolution blocks. So with these help and the depth-wise convolution, with these help, we are capturing very soft tissue textures, right? And then we have the vision transformer, where we have what it does is that how tumor boundaries influence surrounding CNNs, and it basically allows us So it basically is allowing us to have overall, like in an image, how is this part of the image corresponding to the other part of the image, and how it is important to determine if the certain area is important or not. So that's where my vision transformer is coming in. And these two are my main feature extractors, right? So we have the deep learning and we have the handcrafted features. So after that, we'll be looking into how if we take both of these features together, how that would be performing. Maybe certain features missed by the deep learning models would be helped by the handcrafted features. So we are looking into that next. So this was feature importance that we did. So in this case, what we have is that we have done feature important analysis on the hybrid feature extractor. So we have extracted our handcrafted features. We have extracted our deep features. And what we are doing here is that you can see, I cannot exactly show, but okay. In certain class, we have two clusters in this graph, right? Take the first graph on the top right, and you can see that we have two clusters here. So what are these two clusters actually representing is that one side on the y-axis we have the probability of the tumor, and on the x-axis we have the feature value. So what we are saying is that my features certain value, as it increases, we can say that if the size of a certain cluster has increased and the probability has increased, so we are saying that okay, this feature is allowing us to help
I'm sorry
this
to interrupt, but you have 1 minute
yes,
to
ma'am.
conclude.
Okay, so this feature is allowing us to predict the tumor more better. So the first experiment that we had was the deep feature extractor, where we had the deep features extracted and all the classifiers. We compared their performance, where we had the random forest perform better. And in the next case, we have the handcrafted feature extractor with the three classifiers. In this case, we have we see that these descriptors reflect the domain specific. We know that handcrafted is very texture and granularity, and it captures very texture details, right? So in this case, we can see that my SVM is performing better, and with the help of SVM, my ensemble model is also performing better. So then next we have the handcrafted plus the deep features. In this case, there's not much better performance than random forest, but yes, so it allows us to tell that random forest is already performing well with my deep features, so allowing its a strong classifier with the SVM. So it's not performing that well together, but alone it's random forest in itself is doing quite well. So in conclusions, we can say that my hybrid class strategy has been um, stable across all experiments, whereas my random forest is performing quite well with the deep learning features that we have extracted. And future work could include improving the size of the data and working with the 3D images and involving more transformers based multimodal architectures. Yes, I'm open to any questions.
Thank you, ma'am. No questions from our side.
Okay,
Uh, Now we'll be moving towards the closing remark.
okay. Thank you.
Thank you, ma'am.
Has the screen sharing stopped?
Yes, ma'am.
Okay.
Now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9th version of the conference. We'll be happy to have you in 11th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I also thank our session chair for being in the session. And now I request everyone to kindly turn on their cameras for a quick virtual snapshot. I request everyone to kindly turn on their cameras for a quick virtual snapshot. Thank you, everyone. Let's meet in 2027. Thank you, everyone. Thank you. Thank you.